My name is Charles Kibert. I'm a professor at the University of Florida, and I'm also the director of a Center for Construction and Environment, which deals with a sustainable built environment and how to achieve it. At least in the commercial sector, there are some objectives at national level, and one of the objectives is to have commercially viable net zero energy buildings by the year 2030. That's an objective, and that by the year 2050, all buildings in the U.S., all new commercial buildings would be net zero buildings. In the residential sector, and it varies by location. For example, the state of California has a very ambitious program for net zero buildings. They are mandating that all residential construction, that is all homes in California, be net zero by 2020, and that all commercial buildings be net zero by 2030. There's other areas of activity, for example, Austin, Texas, which is a very progressive area of green building in the U.S. They are mandating that all residential construction be net zero by the year 2015, which is just a few years off. So we're starting to see a lot of local programs spring up around the country as people start understanding that controlling energy costs and becoming energy independent. And there's also a lot of local concerns about climate change, so using renewable energy and creating net zero buildings contributes to reducing our carbon footprint in the U.S. The simplest version of net zero is that you look at your electric meter at the start of a year, and your house is generating energy because you have photovoltaics, and you're sending energy out to the grid during times of the day when you're not occupying your house, and so the energy company is paying you money theoretically for the energy you're exporting. During the evenings and weekends when you're using the house, you're taking energy back off the grid because you need it in evenings, for example, or times when there's less sun. Net zero would mean literally that two-way flow of energy in your meter at the end of the year would read zero. You would have used no net energy at all because you've actually exported as much to the grid as you've taken from the grid, and therefore your net use of energy is zero, your energy bill is actually zero as well. There's a database of 10 pilot projects in the United States that's been in existence for about 10 years. So this represents the slow growth phase. The newest large-scale net zero building in the U.S. is in Colorado. It's called the Research Support Facility. It's at our National Renewable Energy Laboratory. And this building is a 22,000 square meter building of about 4 stories. And it's a net zero building that has about a 1.6 megawatt photovoltaic array. One of the issues of net zero is how to actually reduce energy consumption so that the cost of photovoltaics will be reasonable and that the net benefits are positive for the building owners. If you don't have a lot of building footprint or you don't have a lot of site area, for example, in an urban area, making net zero buildings would be impossible. And so in the state of California, for example, they realized this was a problem and they redefined net zero such that you can actually generate your electricity, your renewable energy off-site through a biomass plant, through wind energy, and you can buy that energy through the grid. In some areas of the U.S. and by some certification systems, they actually don't permit this. They say that as part of the certification process, you must generate all your energy on site, and it must be 100% renewable, and it cannot be from combustion. So you cannot use, for example, biomass in that scenario. So there are some struggles with definition, but I believe the Californians have it right, that you do need, in order to have larger buildings with smaller sites, you need to have the ability to generate your energy through renewable sources off-site. Otherwise, you're stuck with a whole landscape of 2-story buildings, because 2 stories is about the maximum size building you can build and still generate your energy on the roof of the building and do it at large scale. So we need more flexibility and more reasonableness and logic in terms of how we do this.